walls. It's very interesting topic, and I will show you some videos which make it interesting. Retaining wall, we have difference in level between one side and another side, and we need to support soil to prevent any collapse. Sometimes your retaining wall is using as aesthetic or landscape design functions. So the main target for retaining wall to hold back soil from a building or structure. As you see here, we have a car. Without this retaining wall, we can expect failure in this soil because we have difference in between. Also, in some construction, maybe you need to do some excavation in your building to be able, this is for high-rise building, to able to construct your foundation, deep foundation like pipes, and then construct your pile caps. Then you can construct basement or garage, everything underground. So we need to do more depth of excavation. So during your construction, how can you make this site stable? Especially if you have building here. This building will make pressure on this soil, so can cause collapse during your construction. Let's see the first video.
Hey guys, I'm here. Everybody, we just started. They dumped the army.
Yes.
There's a marker. I can't get it.
Here's a marker, just kidding.
Oh, this one is good. I'm not gonna
Hey, can you watch this video? Some people trying to make excavation for this area to prepare the site for foundation. So we have more depth, very deep excavation. So we need to support this side of soil. Your soil is sand or clay or something, so we need to support this side. They did, but something wrong happened. Can you watch this building?
Arkadaşlar hepiniz sağdan gelin yukarıya. Gelin yukarıya hepiniz. Mustafa malzemeyi al gel yukarıya. Al gel yukarıya.
It's Turkish.
Alın gelin yukarıya. Gelin çok geliyor hadi. Arkadaşlar hepiniz gelin. Sahilde gelin. Sahilde gelin.
Soil failure. Can you watch this amount of soil? One more.
Hadi rica ederim ya gelir aşağıya yakın gibi var. Maçaya buradan şansın var. Ya git abla git. Durum maçayasını alır. Kameraya çekiyor biraz.
These engineers and designers.
Bırak şu makineyi.
They're building now.
Wow, can you watch what happened for this foundation for this building? The soil escaped. Yeah, you can expect failure for this building.
Maybe.
Yeah, maybe. It doesn't happen, but
Yes.
maybe. Because as you see here, the foundation
Just Tuesday.
without soil. So
They're good. They
let's
use
try
them.
another one. And also there is broken in the water pipe. Can you see? More damage. More damage. The designer will pay not too much. One more.
He used the wrong feet.
This is an example of a retaining wall failure, a familiar hazard in ground engineering.
Can you see what is the idea behind your retaining wall? Here is your retaining wall. Here is the soil supported by this retaining wall. And here is your building, maybe on this soil. What do you expect for the soil will cause any failure for this retaining wall? What happened? This soil trying to push this retaining wall like this.
An engineer designed a wall to hold the dry, sandy soil whilst houses have been built above. Examples of this can be seen where roads or railways or other excavations have been built that cut into the land. Unfortunately, this wall has not been designed correctly and has started to fail. This slope failure is translational in nature, and you can see the slip planes that have formed. Slope failures in wet clays and silts tend to fail at shallower angles and be of a rotational or flow type failure.
So, can you turn on the light, please? So today we are going to talk about retaining wall which supporting soil. We have different type of retaining wall. We have many types. First type, which called gravity retaining wall. We have huge amount of concrete forming shape of retaining wall, supporting soil behind. The stability of your retaining wall based on the huge amount of retaining wall makes this stability. So you are depend on stability, self-stability of your retaining wall because we have huge amount of concrete. So it's called gravity retaining wall. A retaining wall that relies solely on its own weight to stand up, which is called gravity wall. So the weight of the retaining wall will make stability for this retaining wall against the soil. The second one, or the second type, which called cantilever retaining wall, thinner than this one. Huge amount of concrete, less amount of concrete. But can you watch this retaining wall? This soil at this area. Do you think this soil will make stability or instability for the retaining wall? Both of them. The weight of this part of soil on this part of the retaining wall makes stability. But at the same time, this soil will make pressure on the retaining wall. So you are making some kind of equilibrium between the pressure of the soil and weight of the soil to make this equilibrium. So as usually of reinforced concrete, this one most of the time is plain concrete without reinforcement, just concrete, huge amount of concrete. But this one, it's reinforced concrete. We have to add steel rebars. So it has much thinner stem, this one called stem, thinner in comparison to this one, and utilize the weight of the backfill soil to provide most of weight. This soil This backfill soil will provide most of the resistance against sliding or overturning. We will talk about sliding and overturning later. Are the most common type of earth retaining structure. Most of the time we are using this type of cantilever retaining wall. The third one, or the third one, which called sheet piling retaining wall. Your retaining wall not made of concrete, no. It's was made from steel, steel pile, or corrugated steel pile. Let's see this video and see how can we construct this one.
Engine 314, traffic collision, unknown of injuries, runway at 20.
Your sheet pile made from steel. We have many units, as you see here. Not only one unit. No, they are separate units like this one. And see what will happen. Can you see the shape for one unit? At this edge, for this unit, we have another edge here for the previous unit, which called male and female interlock between the two parts. So this machine, or this he will try to put the male and the female interlock alignment, as you see it. He is pushing it down. At the same time, he makes some vibration to enable to penetrate the soil by this unit.
Also, it's not pre-dug. He's like stabbing it in there.
Yeah. Someone will ask me, hey, we don't have difference in ground level between this side and this side. No, he will start first to penetrate this sheet pile, then he will start to excavate this soil. You know? So he is driving the sheet piles first around the area of the construction, then he will remove this soil or do some excavation. He is checking for the vertical level. For this kind of sheet pile, what is that? Here is the ground surface. He put sheet piles at this location, and he will start to excavate this area until reaching the required level. This sheet pile is still working as a cantilever. How? Yeah, you should have some lens embedded in the soil to make fixation for this sheet pile. I cannot do or continue to excavate until this point. So do you think this one is stable? This one, we don't have anything here to support this end. So this one will be like hinge, allow for rotation, that's fine. Nothing support this end. So you have something like this. If you push this beam, you can expect failure. But you have to provide some lens here, because this lens will make this cantilever as fixed. If you have beam, vertical beam with fixed support, still stable if you're trying to push. That's right? That's right? Okay. We have another kind of retaining wall. Okay. Actually, this lens is too much, 30 feet. So if you add 30 feet plus something here like 10 to 20 feet, it will be too low.